Hello and welcome to my ENEL384 project demonstration video. In this project we had to take a 74HC166 and 74HC164 and use them to serially transmit the position of a 4-position dip switch and display that on a 7-segment display. So here is my schematic. It's not super conventional because it just uses all signal flags. So over here you have your switches. There are the 8, the 4, the 2, and the 1, and those are pulled down through a 10K resistor. Though the 8, the 4, and the 2 signal, those go into the 166, and then of course the other unnecessarily part of the, because this is 8-bit, the rest of them are tied to the ground or 0 there. And then the serial version is transmitted on the SW data flag over to the 164. And then, of course, you got your 1 transmit, your 2 transmit, your 4 transmit, and your 8 transmit. So those are the transmitted bits that were received. And then those are fed into your 1T, 2T, 4T, and 8T. Those are fed into the 4511 over here. And then those are outputted here through your 270 ohm resistors and to the 7-segment display. Now, of course, this isn't the full thing that I've explained here, but you also have these 74HC00s and the 14. Those are used to detect what clock pulse we're on, and to do some other functions. For example, this the last inverter here, or the first inverter in this chip, takes the clock and makes an inverted version of it, so that way we can get proper timing. As you can note, the 166 and 164, and by definition the 4511, they're all running on clock star. That way, when their rising edge comes, the appropriate number pulse is already on the counting bus, because the 166, no, not the 166, the 161 is tied to the normal uninverted clock. So that way things just sync up properly, because the shift registers rely on a rising edge. And so you have to have the correct number before the rising edge that is needed for these shift registers it comes. So then, specifically, these chips are used to detect a 1, a 9, and a 10. So when the one count is detected, or on the first pulse after the 0th part of the cycle, that 1 drives the, where is the signal? The 1 drives the 166 latch pin low, so it reads the switches. And then, of course, for the next 8 pulses, that transmits the 8 bits to the 164 here. So then right on that last, on the 9th count pulse, as part of that 8-bit transmission, the 9 detect goes low, and that latches the 4511. So then it displays the number on the 7-segment display here. Then finally, when the 10th count comes from the counter IC, that goes into the parallel input or enable input on the 161, and because the parallels are all tied to 0, that means the counter resets to 0 and the cycle can start again. That's how this works. So then let's go have a look how I made it on the board here. We'll just turn this off for now, because it don't need to be on. So up here in this giant forest of wires, you have my switch. And then you have the 10K resistor bus over here, and that ties the switches to ground, and then you can see they get attached to 3 volts by the switch. Then literally right in there, you have the 166, and then just below it you have the 161. That keeps track of the count. Then you have the first, the top 00 and then the second 00 here, and then you have the 74HC14, and then of course all of those keep trigger on specific count pulses or specific numbers from the counter. Then over on this other breadboard here, you have the 164 here, and then the serial data, it comes specifically on this wire here. And then this one is our clock star that both the shift registers are running on. And these 4 green wires here, this little bunch going here, those are the transmitted data, and those go into the 4511 here. And then all these red wires go to the 270 ohm resistors here, and then of course those go to the 7-segment display. And then what else should I say here? I guess this wire here is the 9 detect wire to trigger the latch mechanism inside here, and then this red wire down here, that is the 10 detect to reset our counter. You see it goes to the last pin on the counter, which is the parallel enable. So let's demonstrate this guy. So we've got our software running here, set for 500 Hertz. And so let's first turn on the board. And so it defaults to displaying 8. Shows up a little bit bright on camera there. So let's run it to 500 Hertz. And as you can see, it displays a 5. Or at least to my eyes, it's displaying a 5. It's supposed to be displaying a 5. When you turn off the counter, then those other segments that are flashy there go off. So, but it is set to a 5, as you can see. We have a 4 and a 1 depressed, so it is supposed to be displaying 5. So let's rerun the counter here. So it kind of flashes there. I'm not sure why. Let's set this to 0 so we can just see a 0 on this. Let's fix all that. There we go. Those are all set to 0 now. You can see they're all set to open. And we indeed are getting a 0 with no randomly flashing segments. So let's put this up the top one up here so we can see an 8. And you indeed get an 8 on the bus there on the 7-segment. And then get it back to 0. Now let's put a 4 on the bus here. See what we got. And we do indeed get a 4 with those segments flashing. And then if we turn off the clock, the 4 does actually settle down. The segment display settles. So we're getting that 4 there. And then turn that 4. Let's check a 2 here. And we do indeed get a 2 with that one segment kind of flashy there. You can tell that's a 2. Turn you back to 0. And we get a 0 again. And let's put a 1 on the bus here. We do indeed get a 1, but you can see all the other segments are kind of flashing. They're not very bright to my eyes here. The camera makes everything look very, very bright. And we go back to a 0 there. Let's dial in a 3 on here. We do indeed get a 3, and this one doesn't have any randomly flashing segments, which is nice. So you can actually make out that it is a 3, indeed. Dial in a 6. Yeah, that's a 6 there. And then a 7. Kind of looks more like a 3, but that was just 2 random segments flashing. I mean, you can see it's just the brighter segments make up a 7. What else should I do for you? Oh yeah, what happens if we dial in a full 15 here? So this kind of goes funky. When you put in a 15 here, the segments go kind of dark and make a 7. So I'm not sure why this. I think the thing should be going blank because this shouldn't be able to do anything with anything that's over 9. So yeah, that's my demonstration video.